Today we are going to talk about oxy acids of phosphorus. We are being given three compounds H3PO4, H3PO3, H3PO2. So first we'll try to find out the oxidation number or a simple equation way, and then we'll try to understand what the oxidation number talks about the acidic strength, and then we'll also draw the structure for the oxy acids of phosphorus to understand what structure of what type of answer can be deduced from the structure. So let's start the mathematical equation. First, let us check the H3PO4. So H3PO4, yeah. Now we have three hydrogen, one phosphorus, and four oxygen. We have three hydrogen, one phosphorus, and four oxygen. As it's a neutral molecule, so we will make it a zero. We'll make it zero. Okay, so we'll write it like this. Oval shape is zero. Okay. Now, as we know that hydrogen have the oxidation number of +1 and oxygen have the oxidation number of -2. So we'll put this value respectively. So we get 3 into 1 plus phosphorus plus 4 into -2 is equals to 0. Okay, we'll write 0 properly like this. Okay. So 4 into -2 is -8 and 3 into 1 is 3. So 3 plus p minus 8 is equal to 0. We get 3 minus 8 is minus 5 is equal to 0. So we get p is equal to 5. So this is the answer for H3PO4. So for H3PO4, we have oxidation number of phosphorus as +5. So similarly, we can find out the oxidation number of H3PO3 and H3PO2. H3PO3 and H3PO2. Okay, so we have three hydrogen, one phosphorus, and three oxygen is equals to 0. We have three hydrogen, one phosphorus, and two oxygen is equal to 0. So again, putting the same value, hydrogen as +1 and oxygen as -2. We have 3 into 1 plus phosphorus plus 3 into -2 is equal to 0. Same way here, 3 into 1 plus phosphorus plus 2 into -2 is equal to 0. Okay, so we have 3 1 the 3 and 3 into -2 is -6. So 3 minus 6 plus p is equal to 0. Here we have 3 1 the 3 and 2 into -2 is -4 plus p is equal to 0. So in this case, we are getting 3 minus 6. We basically it is p minus 3 is equal to 0. 3 minus 4 it's -1. So p minus 1 is equal to 0. So we got oxidation number as p is equal to 3 and we got oxidation number as p is equals to 1. Okay, so we have oxidation number as 5, 3 and 1 respectively for the phosphoric acid. We have phosphoric acid, which is H3PO4, phosphorus acid, and hypophosphorus acid. This is how the name is coming as. So H3PO4 is called as phosphoric acid. Phosphoric, oh, yeah. H3PO4 is called as phosphoric acid. And when we remove one oxygen for phosphorus, we get phosphorus acid. And if we remove one more oxygen for phosphorus, we get the hypophosphorus acid. So this nomenclature, or you can say this particular naming system is applicable in all the scenario. For example, I will take the similar example. H2SO4 is sulfuric acid. So H2SO3 will be sulfonic acid. So this is sulfuric acid. This is sulfuric acid, and this will become sulfurous acid. This is how the nomenclatures are. Same thing is applicable for nitric acid. HNO3 is nitric acid. So HNO2 will become nitrous acid. Okay. So whenever we see ic acid, like IC acid, if we remove one oxygen for that particular central atom, we get the us acid for that particular oxy acid. Okay, so this is how we are finding the oxidation number for the oxy acids of phosphorus or mathematical way. Now, coming to acidic strength, we already have got the trend of oxidation number in for oxy acids of phosphorus. We know that H3PO4 have the highest oxidation number as +5. So the trend of oxidation acidic strength in this case is the same as the trend in oxidation number. So if you are able to find out the oxidation number of the central atom somehow, then you can also find out the acidic strength of that particular oxy acid, whether it's a phosphorus or a sulfur or nitrogen or anything. Oxidation number, higher the oxidation number, higher is the acidic strength. That is what it is written. Acidic strength is directly proportional to the oxidation number. So in our case, H3PO4 has highest oxidation number. That's why among the given compound, H3PO4 will have the highest acidic strength comparatively compared to H3PO4 and H3PO2. Okay. Now you can practice the similar thing for sulfuric acid and sulfurous acid. Now coming to structure. Uh, Before drawing the structure, you should be knowing this point that oxy acids of phosphorus cannot have steric number more than 4. Means whenever you are getting the phosphorus like this, like 5 bonds, never draw 5 bonds. It is not possible. One of the bond has to be P double bond O. One of the bond has to be P double bond. That's compulsory. Because if you feel that, let's say if you are talking of H3PO4, we feel that phosphorus may have more than 4 bonds. It seems like it may have more than 4. A center atom may have more than 4 bonds, but that's not the possibility because phosphorus cannot have steric number of more than 4 in case of oxy acids. Oxy acids of phosphorus cannot have more than 4 steric number. Okay, so one such case has to be P double bond O has to be present. So what we can do, we will draw the structure of H3PO4, H3PO3 and H3PO2 parallelly so that you can understand exactly how to differentiate the structures in exam and what we can deduce from the structure. So we will draw P double bond O for everyone as per the instruction written here. This is P double bond O, P double bond O. Okay, so cannot have more than 4 atoms. So let's draw the 4 steric number like this. Let's draw the 4 steric number like this. Okay. We have already consumed 1 oxygen here and we still have 3 oxygen here. So we can write 3 oxygens like this here. Here we have consumed 1 oxygen. We are left with 2 oxygen. Here we have consumed 1 oxygen and we are left with only 1 oxygen. Now remaining 3 hydrogen can be attached like this. Like this. Okay, so this is how you can remember the structure. So ultimately, I can say that this particular thing, where is the eraser? Where is the eraser? Okay, we have the eraser here. Okay, yes. So I will draw this hydrogens attached to the oxygen directly, like this. Okay. Now, what we need to remember here is that hydrogen, which is directly attached to phosphorus, is not the acidic hydrogen. Okay, I am repeating the statement. Hydrogen, which is attached to the phosphorus, is not the acidic hydrogen. ये phosphorus को जो डायरेक्टली अटैच किया हुआ हाइड्रोजन होगा वो एसिडिक हाइड्रोजन की तरह बाहर नहीं निकलेगा. तो एसिडिक हाइड्रोजन की तरह बाहर निकलने वाले कौन से हैं? विच हाइड्रोजन विल बी एसिडिक हाइड्रोजन? Only those hydrogen which are attached to the oxygen directly. So I will take a different color. This particular hydrogen is attached to the oxygen. This hydrogen is attached to oxygen. This hydrogen is attached to oxygen. So these are called as, you can say, protic. Uh, it contributes to protic acid, or it contributes to, you can say, acidic strength of that particular molecule. So as we can see here, that H3PO4 is having 3 hydrogens which are protic. Okay. So in this case, we have one hydrogen which is protic. So I can say this is monoprotic acid, or I can use another word, monobasic acid, because H3PO2 has only one hydrogen available for contributing to acidic strength. Same thing we can say for H3PO3. It has two hydrogen, so we can say it's a dibasic acid or a diprotic acid. It can be a diprotic acid, or it will be a oh, it will be a dibasic acid. And what about this? We have three hydrogen here. So in this case, we can say that it's a triprotic acid, or it's a tribasic acid. So even on the basis of the structure, we can say that H3PO4 is having the highest acidic strength. But for that, you need to remember this point, that oxy acids of phosphorus cannot have steric number more than 4. So likewise, if you are getting some different oxy acids of phosphorus, so your first job is to understand that P double bond O has to be there. So draw one P double bond O, and then attach the other atoms to the remaining three bonds of the phosphorus. So this will make the things simple for you. So this way you can find the oxidation number. You can predict the acidic strength based on the oxidation number. Same thing goes with the structure also. Structure also tells us that the structure gives us the exact details, that how much acidic, you can say, how much acidic strength does the phosphorus have, oxy acids of phosphorus have, relatively related to each other. Okay. So this is all about the oxy acids of phosphorus. We will discuss more molecules with respect to inorganic chemistry. Thank you for now.